Number 7, the wheel in this figure here has 8 equally spaced spokes and a radius of 30 centimeters. It is mounted on a fixed axle and is spinning at 2.5 revolutions per second. You want to shot a 20 centimeters long arrow parallel to this axle and through the wheel without hitting any of the spokes. Assume that the arrow and the spokes are very thin. Letter A, what minimum speed must the arrow have? Letter B, does it matter where between the axle and ring of the wheel you aim? If so, what is the best location? Okay, so let's draw our wheel over here. So this is the center and we have 8 spokes, right? So those are 2, 4, 5, 6, 7, 8. Okay, so those are all our spokes. Let's suppose that the wheel is spinning in this direction over here, this orientation. Okay, so let's imagine that you throw an arrow, let's say for example over here. And then what's going to happen is that this spoke over here will start traveling towards the arrow, right? It's going this way. And if it hits the arrow before the arrow has passed completely through the well, so that's what we don't want to happen. So as you can imagine, the best location that you can shoot the arrow is as close as possible to the next spoke. So as close as possible to the next spoke. So you have the time for the previous spoke to travel this angular distance here. So you have this angular distance which is equal, this angular distance which is equal to 1 revolution divided by 8. So 2 pi radians divided by 8. So our arrow must be faster or fast enough so it should pass through the wheel completely before the well turns 2 pi over 8 radians. Okay, so let's calculate how long does the well takes to rotate by 2 pi over 8 radians. Okay, so remember that the angular velocity is equal, if this is constant, we can write this as the angular distance or the angular displacement rather divided by the time. So the time, which is what we are looking for, is equal to delta theta over the angular velocity. So delta theta is equal to 2 pi over 8 radians, and the angular velocity is equal to 2.5 revolutions. So let's just write it over here. This is 2.5 revolutions per second, and remember that a revolution is 2 pi radians, so this is 2.5 times 2 pi radians per second. So this is going to be 2.5 2 pi times 2.5 radians per second. So we can cross this out over here and we will find 0.05 seconds. So that's the time the arrow have to cross the well entirely. So we have what we have the length of the arrow. So now we can apply this equation, v equals to delta x over delta t. So delta x is the length of the arrow, or 0.2 meters divided by 0.05 seconds, and this gives us 4 meters per second. Okay, so that's the answer of letter A. 4 meters per second, it's the minimum speed that the arrow must have. For letter B, does it matter where between the axle and the ring of the well you aim? If so, what is the best location? Okay, so the thing here is that it's asking if it's better to shoot like this position or 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 this position. So this doesn't matter, because what matters is the angular displacement of the spokes. So it doesn't matter the radius of where you shoot. Let's say the distance from the rotation axis, it doesn't matter. So letter B, it doesn't matter. One thing that you should aim for, I'm not sure if you can aim for that, but when the arrow starts, when it start crossing the well, it should start crossing the well like as close as possible to the next spoke. So that's all you have to aim for.